Hello and welcome. In this video, we're going to be looking at another tough Mechanics 1 question from the Edexcel January 2022 exam. This question is pretty unique, so we're going to have a look at it. This question requires you to have firm understanding of friction, maximum friction, and the keywords like on the point of sliding up or on the point of sliding down. So let's see how we can approach this question. Let's start by reading the question. It looks like we have an inclined plane. So it says a particle of mass m, we're not giving the actual mass, rests in equilibrium on a fixed rough plane. What does rough tell me? Answer. If your answer was friction is going to be included, then you are correct. So the word rough tells me that there will be friction included. So a rough plane under the action of a force of magnitude x. The force acts up the line of greatest slope of the plane as shown. The plane is inclined at an angle alpha to the horizontal, where tan alpha equals 3 over 4. The coefficient of friction is mu. And it tells me when x equals 2p, the particle is on the point of sliding up the plane. So when the force is 2p, okay, it's greater, okay, so it's high, it's a high force. The particle is about to slide this way. But when the force is reduced to p, the particle is on the point of sliding down the plane. So when the force is p, okay, that force is barely enough to just keep it in its position. It wants to go slide this other way. And this is super important idea. Let me go through friction idea with you super quickly. Let's say I have a box, okay, and I'm pushing it with 10 newtons. The box is not moving. What does that mean? That means that there must be a force in the opposite direction, because if there were no force, my resultant would be 10 newtons to the right and the box should move to the right. However, since it's not moving, this tells me that there is another force with equal magnitude, okay, in the opposite direction. This force is a resistive force. We call it friction force. Okay, let's say I got two of my friends and we're now putting more force. We're putting, let's say, 20 newtons, and we find that the box still doesn't move. That means that the friction now increased to 20. So the friction increased, right? What about if I made my force 25? The box is now not moving. However, it's on the point of sliding to the right. What does that mean? On the point means that if my pushing force is increased just a tiny little bit, it will start moving. So this is our threshold, or this is the maximum it can hold. The maximum the friction can hold is 25 newtons. The friction can go only up to 25 newtons. So this friction, which is 25, we saw that the friction can take multiple values. First it was 10, then it was 20. 25 is the F max, is the maximum friction it can take. Why is this important? Because friction or max friction has a unique equation or a unique formula. It's equal to the coefficient of friction times the normal reaction, which is going to be the reaction that is perpendicular to your surface. Okay, so I can only use F equals mu r when I have, or I'm sure that my friction is maximum friction. How do I make sure? From keywords in the question, like on the point of sliding up, or about to slide, or basically another word is limiting equilibrium. This also indicates that we are at the threshold of equilibrium. Any tiny little bit increase in force is going to make me move out of equilibrium, is going to make me have a resultant force and thus acceleration. So these three keywords are indicating that we have maximum friction. And by the way, I've done a full mechanics course. Okay, it's super useful on Udemy. Feel free to go check it out. It's literally a gift I would have given my younger self. It has everything from theory to solving to past papers to topicals, every single thing you need to know, and a revision section at the end with all the keywords combined for you for your revision. It's literally all you need to get the mark that you want. I'm gonna put it on the top right hand corner. Feel free to go check it out, and if you want to get it, send me. I'll send you a discount code. Anyways, so let's continue this question. Now that we know the idea about maximum friction and we know that these keywords indicate that we have maximum friction, let's start solving the question. So as always, in these types of questions, you always have to draw what is happening. You know that this is alpha, you know that this is your object, and we start to draw the free body diagram. So we draw all the forces that are acting on this object. So obviously we have the weight, which is going to be the mass times g, okay? We have the normal reaction force, which is going to be in this direction. Let's call it R. We have the X force in this direction. Let's start by doing the first part where X was 2p. So instead of X, I'm just going to put it as 2p. Okay. And this is going to tell me that when x is 2p, the particle is on point of sliding up the plane. So if the particle is about to move up the plane, where do you think the friction or resistive force or opposing, literally from its name, opposing force, where is it going to be in terms of direction? Obviously, if I'm trying to move up, the opposing force is going to try to move me down. So the friction force is going to be in this direction. And we know it's friction max. How do we know? Because particle is on the point of sliding up. So instead of F, I can just put in instantly that's going to equal to mu multiply R. Now I have all my forces. Let's see the forces that I'm going to resolve. I'm going to resolve my mg because this is my x and y. This is my x and this is my y. These are the coordinates. I want every single force to be aligned with them. And this is explained thoroughly in my course. If you want to go, feel free to go check it out. So mg is going to have a component this direction and a component in that direction. So this angle is going to be alpha over here. Since I'm closing on my angle, is going to be mg cosine alpha. And this is, since I'm moving away from my angle, is going to be mg sine alpha. Now, let's deal with alpha to get rid of it. So it tells me that tan alpha is 3/4. I know that tan in a right angle triangle, so if we draw like a simple right angle triangle, this is a right angle over here. If we call this alpha, we know that tan is opposite over adjacent. So opposite is 3, adjacent is 4. What's my hypotenuse here? Super easy. I can use Pythagoras. 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. 16 plus 9 is 25, so this is equal to square root of 25, which is going to give me a value of 5. So my hypotenuse is going to be 5. Now, this will allow me to get the answers for cosine alpha and sine alpha, because clearly I need them in my solutions. So cosine alpha is going to equal adjacent over hypotenuse. So adjacent is 4, hypotenuse is 5. Sine alpha is going to be opposite 3, which is the opposite, which is 3 over hypotenuse, which is 5. Now I'm ready. Let's now resolve, okay, our equations and get our equations of motions. First of all, here it's on the point of sliding. I don't have any acceleration. This is a case where we are in equilibrium. So when we are in equilibrium, I will use sigma forces equal 0, because usually sigma forces equals ma. Since a is 0, so sigma forces equal 0. That gives me a hint that forces in opposite directions are equal. So when I'm resolving, let's first start to resolve in this y direction. So in the y direction, let me say I'm resolving in the y direction. I know from this that sigma f equals 0. I know that the opposite forces are equal. So the forces pointing in the positive y direction, like r, are going to equal the forces pointing in the opposite direction, which is mg cosine theta. So here I'm just going to have r equals mg cosine theta. What is cosine theta? It's 4/5, so it's going to be 4/5 mg. This is my first equation. Now let's resolve in the direction that is parallel to the slope. Again, acceleration in that direction is 0. So I'm going to say that opposite up the slope are going to equal opposite down the slope. So the forces up the slope are going to equal the forces down the slope. So the force that's up the slope is 2p. Any other force up the slope? No. So this is going to equal the forces down the slope, which is going to be mu times r. Mu times r. Instead of r, I can use 4 over 5 mg. I got that from the first equation. That's why I always encourage you guys to start resolving in this direction, always, because you're going to use it in the other part. So mu times r, so mu times 4 over 5 mg. And then adding to that, this mg sine theta. So sine theta is 3 over 5, so plus 3 over 5 mg. This is now my first equation from the first part over here. The question wants me to find mu. So let's now think about the second part. Let's just copy this because we're going to need it. Let's copy. So now it tells me when x is now different. X is now no longer 2p, it's now p. The particle is on the point of sliding down the plane. So again, if I came here and I pasted this, okay, now let's remove these the forces in the direction parallel perpendicular to the slope are not going to change. We're just going to have an r and an mg cosine theta. This mg sine theta is also not going to change. The only thing that's going to change is this 2p. Instead of being p, instead of 2p, it's just going to be p. And now what changed is that the particle now is on the point of sliding down the plane. If I'm on the point of sliding down the plane, the force that's going to oppose my motion is going to be pointing in the upwards direction. So now my friction, here my friction was downwards because I was on the point of sliding up. When I'm on the point of sliding down, my friction is going to be in the direction opposite to that. So my friction is going to be in the upwards direction. So friction is going to equal mu r. Again, from here, r is going to equal mg cosine theta. So cosine is 4 over 5 times mg. Now, this is resolving in the perpendicular direction. Now, let's resolve in the parallel to the plane direction. Again, forces in one direction will equal forces in the other direction. So forces up, such as P plus mu times R. Again, R is 4 over 5 mg. These are the forces up. They are going to equal the force which is pointing down, which is mg sine theta. So sine theta is 3 over 5 from here times mg. Now, let me copy the first equation that I had over here and paste it down. Now I have two equations, okay, with p and mu. Now I can use those two equations to solve for the unknown, which is mu. So straight away, I can see that I can rewrite this equation to p equals 3 over 5 mg minus 4 over 5 mu mg. And I can see that I can substitute this p all the way over into here. So now this is going to be 2 times, instead of p now, I'm going to put in this. So instead of p, I'm going to put in 3 over 5 mg minus 4 over 5 mu mg. And then I'm going to put the equal sign, equals to 4 over 5 mu mg plus 3 over 5 mg. Now I can notice something, that mg occurs in literally everything. So I can cancel out an mg from every single term. And if I multiply this 2 inside, it's going to be 2 times 3 over 5, that's 6 over 5, minus 2 times 4 over 5 is going to be 8 over 5 mu, equal to 4 over 5 mu plus 3 over 5. So what I'm going to do is I'm going to move this 8 over 5 to this direction. It's going to become plus. And I'm going to move this 3 over 5 into this direction to become minus. So I'm going to have a 6 over 5 minus 3 over 5 equal to 4 over 5 mu plus 8 over 5 mu. So subtracting here, 6 minus 3 is 3 over 5 equal to 4 plus 8 is basically 12 over 5 mu. So I can cancel this 5 with this 5. So I'm going to have 3 equals 12 mu. Divide 12, divide 12. Mu equals 2. This is 1 over 4 or equals to 0.25. And this is going to be my answer to this question over here. So in these questions, it's always best, guys, to actually understand the keywords, to understand every single keyword and every single word, what it means. If you watch my other videos, which I'm going to link in the top right hand corner, if you watch those videos, always, as I'm reading the question, I always underline keywords and I ask you, what does that mean? What does it mean by rough? What does it mean by saying inextensible when we have a string? What does it mean by saying light string? And all those things. These are super important. And again, they're summarized in the course that I did on Udemy. Super useful. Check it in the description down below. Please don't forget to leave a like, subscribe, and if you have any questions, leave them in the comments down below. Any suggestions for future videos, leave them in the comments down below. I'm going to read them all. I'm going to try to help you. Thank you so much for watching and have a nice day.